Hello friends, today I'm going to talk about Leetcode 1737. Change minimum characters to satisfy one of three conditions. You are given two strings A and B that consist of lowercase letters. In one operation, you can change any letter in A or B to any lowercase letters. So your goal is to satisfy one of the three conditions. The first condition is that every letter in A is strictly less than every letter in B in the alphabet. The second condition is every letter in B is strictly less than every letter in A in the alphabet. The third is both A and B consist only one distinct letter. So you have to return the minimum number of operations needed to achieve your goal. Here are two examples, and let me explain these questions. So here, for example, we have example 1, ABA with CAA. So we have to change if we want to satisfy the condition 1 or condition 2, we have to change the letters in A and B. So for example, we can change B to CCC. Then every letter here is smaller than CC, right? So we have to do the two operations. And if we want to satisfy the condition 2, so we have to make the B is strictly less than A. So we can change this B for A, and change the CAA to AAA, right? So this satisfies the condition 2. And if we want to satisfy the condition 3, condition 3 description is a little misunderstanding for the distinct. I think maybe we can just delete this distinct. So it means only one letter, one special letter here. So either we can change that, change it to this BB or A. That is only one operations. Or we can change this is AA, only one operation. So here is two. And for here, how many operations? Here is 3. So the answer is 2 among of them, which is the minimum number of operations. And another example is this example DABADD with CDA. So one operation is that is we found that all the numbers, that is if one smaller, so we can change it's to CC. If we want to satisfy the condition 1, so we can change it as EEE. Only change B, so it's the answer is 3 here. And if we want to satisfy the condition 2, we have to change at least more than 3. For example, we change this we can change this I need to change this D. So D is I need to change is C. Here if you say here is D, you see here C A C A C C. So it's how many? 1, 2, 3, 4. This is B. So it's 3 plus 2 is 5 operations. And if we want to make them to satisfy the condition 3, for the condition 3 we have to make them all the equal. So it's D because D has the maximum number. So here is D. So it's also more than 3. So it's bigger than 3. So we have to so the answer for this is 3, the minimum number of operations. Actually, if for the naive solution is that we have to compare each characters in A. This naive idea is each characters in A and compare every letters with B, and then we decide whether we need to change the letters and to make satisfy the condition 1. And also we need to traverse the every letters in B to make sure every letters in B is B with every letters in A to make sure every letters in B is bigger than A. So with these 2 loops we can get these answers for condition 1, and same for the condition 2. We also do the 2 loops, and for this condition 3 we do not need to 4 loops. We only get the maximum number of the occurrence the letters here, and get the length the total length length minus the maximum number of occurrence of one letter. So this will take OM times n complexity if M is the length of A, N is the length of B. So is there any better solutions? Or second idea, we can observe that here condition 1 and with condition 2, condition 1 with condition 1 and condition 2 actually are similar, because we can switch the input parameter. Switch the input parameters here. So make the A less than B. Actually, it's similar as make the B less than A. So we have only considered 2 conditions. How we can make A smaller than B? Actually, we do not need to consider how to switch. Assume we have A letter here is AAA, whereas B letter is here in CCC. We can find that there's always a boundary line between A and B if they are already separated. So here this boundary line is B letter. Like here, if we change this is E, there could be B letter and or B or C letter, right? So we can traverse from the A B. We do not need to start from A. We start from B to Z letters and check how many letters in A is bigger than this this center maybe we call center letter. Maybe call bound letter. 然后 then this bound letter and we count how many in B is smaller than this bound, and then we get the sum of them. This is the count of how many operations for one boundary letters. So we have to get the minimum of operations for all the bound letter. So in this way, so we can solve this problem with O m times n times 26. So it's a constant. So we just OM times M plus n time complexity. And for the condition 3 is because we just get the length A plus length B, we mix them together actually, and minus that the maximum occurrence of one letter, and this then we get the smallest the number of operations. Let's write the code here. So first we define the operations for 1, 2 operations A and B here. And for 1 and B operations, we can get we traverse from we initialize the answer count is length A plus length B, and we traverse from the B to Z. We use a number traverse, and we get the bound letter equal to bound letter is R plus O R D A, and we get initialized code. So then we use two loops in A and B. If this letter is bigger than the bound, then we get the count plus 1. And for CI in B, if the CI is smaller than the bound, we get the count increased by 1, and then we return the smallest of all these operations. So they will return on count. So this is the operation on 1, 2, and then we define the operation for the condition 3. For the condition 3, we use a condition dictionary from in Python counter. So we define the characters and we mix them together and counter A plus count B, and we get a counter A plus length B on the maximum occurrence. Okay, we have finished the operation 1, 2, then we just call them to get the minimum of them. So operation 1, 2, A, B. Operation B, A. Let's check the code. Connections, is something wrong? Connections, okay. Okay, let's check it as a test case. Okay. Okay, that's it. Thank you very much for watching. See you next time.